Hey guys, we are Team Tech Transit and our team is very specialized in machine learning, full stack, DevOps and advanced algorithms. We have chosen the problem second, which is about predicting multimodal transport route across borders based on cost, transit and feasibility. From the user side, we will take the destination and origin, the details of the shipment and their preferred priority. And we have done a thorough research on this, and based on the research and reading many research papers, we have found that the solutions that are present are optimized for single mode routes. They are not optimized for multimodals. And solutions that are optimized for multimodal routes have these pitfalls, and they are computationally extensive, they are not scalable, they are difficult to integrate, and they are data dependent. So we have designed our solution to tackle that. And at the heart of our solution is a route optimization engine, which ranks the routes and uses algorithms such as Dijkstra and A-star. The main part of our route engine will be the data. So we have done thorough research on gathering data, and we have gathered these API points which are regularly updated. So we have chosen for land routes OpenStreetMap, for sea routes we have chosen World Port Index, and for air routes we have chosen OpenSky networks. And the advantage of this is that it can be regularly updated, it can be cached, static data can be cached, we can use a database to store all this data so that we can update it regularly and easily. And the route generation engine works using a graph. The graph is made up of all the routes. So the cities, ports and airports are all represented by nodes, and the nodes are connected with edges which are routes. So these edges can be weighted so we can better rank if a user chooses a priority such as land or air or sea. And we will be using Dijkstra, a modified version of Dijkstra and A-star to find optimal paths as fast as possible. And the features which our solution stands out are vehicle. We tell if the route is capable of handling the shipments, or if the documentation are required on the routes, or if there is a danger in handling such shipments on the route. And there are smart optimization factors such as risk assessment and historical reliability of data, peak and off-peak pricing, fuel charges, and currency exchange impacts of the routes. And we have focused highly on user, so we have done many UI UX innovations such as interactive map visualization, real-time route comparison, drag and drop waypoint. We will also show risk heat maps, and we will make it integratable, so we will create a great API so that it can be integrated in any type of systems. And the tech stack will be backend will be FastAPI for API development, Redis for caching, Postgres for storing all this data, and Celery for break contrast, so that the route optimization is as fast as possible. The frontend will be React with Mapbox GL to show the map, charts for analytics, and Material UI for overall the app. Then we will use Docker, GitHub, and Grafana for DevOps deploying the app, and we will also maintain a technical documentation for all this app and the way the system is designed. So if anyone wants to take this further, they can do so easily. And this is what the final app will look like. So the first app shows the overall multimodal routes of all sea, ships, and lands. And you can see in the second image, for a single area, there are land routes, there are sea routes, and there are air routes. And if the image below, you can see all the routes of a single area. And if you prefer to see a single mode route, you can see it in the leftmost image in the PPT. So yeah, this is our solution, and we are a team which is well experienced in this. We can build this, and we will create a great solution for this problem.